everyone. This is Shauna, and I'm here today to provide a second recording for section 2.1. Some of you may have found the recording from the previous semester. There are a couple of mistakes that I did manage to correct in that video, but not until later on. So if you didn't watch the entire video, which I wouldn't blame you if you didn't, because it's rather long, you may have been confused by some of the things that were there. I wanted to provide you with a little bit of an overview of section 2.1. It's a very long section. It's not hard, but it is time consuming. So just be aware of that. Section 2.1 deals with what we call frequency distributions. And those basically are ways of organizing data when we have it. And so the first thing you want to pay attention to in the section is, yes, we have rules for putting the frequency distributions together, but we need to know what type of distribution we're looking at. Now, on the quiz or the exam, Professor Nickdell is not going to tell you what type of distribution you have, and that's because you should be able to tell on your own based on the information that's given to you. So we have three types of distributions. We have, so I'm going to say types of frequency distribution. Okay. The first type is the categorical frequency distribution. Okay. And this deals with, the way you know this is generally not numerical data. It could be, you could be doing something like zip codes or runner numbers, and you could make a case for that being categorical. But generally, this is going to be non-numerical data. And even if it looks numerical, it's not going to be used in that sense. So you have something like class composition, freshman, sophomore, junior, senior, or the type of sport you play. So this is for qualitative data. Okay, that's how you figure that out. So you have that distribution. The second type of distribution is we have what we call an ungrouped frequency distribution. So we have an ungrouped frequency distribution. Okay. And the third one, which is the one I'm going to spend the most time on in this video, because I think it's the hardest for students. The third one is the grouped frequency distribution. Now, how do you tell which one you're supposed to have? Grouped frequency distributions have larger data sets. And for Professor Nickdell's class, a number of classes to use in your distribution will be given. Okay. If some of you have had statistics before or had it in other places, this is one of the concepts that different instructors teach different ways. And when we get to the number of classes, there's different ways to figure this out. There are formulas. Professor Nickdell's just going to tell you how many classes to use. So if she tells you construct a distribution with 5 classes, construct a distribution with 3, then you're doing a group frequency distribution. That's how you know that. An ungrouped frequency distribution means that here you're going to use every distinct data value as its own class. And I'll explain that in a minute. But here you're going to use a number of classes. So those are the differences. Now, what I wanted to also show you was I'm going to come to the homework assignment here and show you something with that. So if you look at the homework assignment, there's only 12 problems, but they get a little bit longer after like number 7. So we have the basic reading questions up here. Why would you organize data in a frequency distribution? How many classes should a frequency distribution have? Why should the class width be an odd number? So I am going to point out this, you can get these from the reading and from the slides, list 5 list reasons. I'm going to point this out. Number 2, I want to show you the slides for this homework, because she talks about the guidelines. Let me go back to the guidelines for constructing a distribution. There's 3 types. We've talked about that. And there's different columns that you can use for each one of those, which I kind of gave you a little bit of that. Now, grouped frequency distributions can be used when the range of values in the data set is very large. Okay. Then she gives you some, we're going to go over this in a minute. Now, here's your guidelines for this. Okay. They have to be mutually exclusive, continuous, all of that, right? If you look at close to the bottom of slide 19, look at step 5. It says, find the width. She means the class width here. Find the class width by dividing the range by the number of classes and rounding up to the next whole number. Why? I strongly recommend that you round up to the next odd number because it makes the midpoint a whole number. Okay. Is that absolutely necessary? No, it's not. Does it make things a lot nicer when we start doing other calculations? Very much so. So the reason that she wants you to make this a whole number, I'm sorry, the reason that she wants you to round up is to make the midpoint a whole number. And by doing so, you make a lot of the other calculations nicer. So the midpoint is going to be a big deal in section 2.2. So I did want to point that out to you. There are instructions for the other types of distributions given, as you saw briefly when I was going through the slides. Numbers 5 and 6 talk about those guidelines that we talked about. Number 7, this is a categorical distribution. Okay, so you're going to follow the categorical instructions for a categorical frequency distribution. Number 8. Now, this number 8, I've had people be a little bit misled here. A survey was taken of 50 individuals. They were asked how many days per week they ate at a fast food restaurant. Construct a frequency distribution using 8 classes, 0 through 7. Now, she gave you the number of classes, that's true. So you would think that it was a grouped frequency distribution. However, this is 0 through 7. And if you look at the data, you have 0, you have 1, you have 2, you have 3, you have 4, you have 5. You don't have any 6s, but you do have a 7. So you can include the 6 with a class width of 0. Here on number 8, use the ungrouped strategy and count the number of zeros, the number of ones, the number of twos, and so forth. But use an ungrouped distribution for number 8, okay? Number 9 is the problem that I plan to do in this video. This is a grouped frequency distribution. It reads, 40 plasma TVs were tested, and the number of watts per hour they used while running for 4 hours per day were recorded. So these are wattage data, what they're telling us. Construct a frequency distribution for the data. Use 6 classes. Obviously, if we're going to use 6 classes and we have like 480 and 473 and 501 and 499, we're not going to be able to use every number and get 6 classes. So we're going to have to group this. This is a grouped distribution, okay? Now, the first thing you're going to want to do when you create a group frequency distribution, I'm going to come back to my slides. It says sort the data. Now, in this section, you can do this by hand if you want, but it's very time consuming. I'm going to do it on the calculator. You do have calculator instructions on Canvas for your data entry. So I'm going to go through that in this example for you here. So now what I'm going to do first is I'm going to come to my calculator. Here's my calculator. Now, I've put the data in my calculator already, okay? But just to show you what this would look like, you would open up the calculator, okay? And you would have a blank list here like L2, and you would put in the number 480 and hit enter, and that would give it to you. You would put in all those data into L1, okay? You put the data into L1. If you make a mistake, let's say you meant to enter 497. You entered 480 instead. You can just type over it, 497. If you miss a number, and then hit enter. If you miss a number, okay, you put 480 down here, and you're like, oh, I should have put 478. You can go back to the place where it should have been. Or if you're at the end, you can add it. You can also use the insert key if you want to insert and put in another number. In this case, if we miss it, it's not going to be all that critical because we're going to sort it anyway. Go ahead and put in your data into L1. Pause the video and come back when you're ready. I'm going to clear this out so that you can see this. I'm going to clear out my L2. And while you're working on that, so let me just welcome back. Your data set should now look like this: 480, 473, and so on. And I have a total of 40 values in this list. Well, how do I know that? A couple of ways I know that. One is if I go to the bottom, I can see that it says L1 and I have a 40 right here. This tells me that this last number is in the 40th position. This little counter comes in handy if you're entering data sets and you have to get up or you get distracted and you forget where you were. The counter will tell you what line you were on. And if you know which way you were going when you did it, then you you can count back and find yourself pretty easily. Anyway, after you enter the data, the next thing you're going to do is sort this data, and we want to sort it so that the smallest number is at the top and the largest number is at the bottom. So it's going up. We call that ascending. So we're going to go stat. And we're going to go, we have two sorts on this menu. We have sort A and we have sort D. We're going to sort ascending, as I mentioned. So I'm going to hit the down arrow key, or I can just hit the number 2. It doesn't matter. I'm going to hit the down arrow key though and hit enter. And I get that. And I have this parenthesis. Now what I need to do is I need to enter the list number that I was using. And I was using L1. Now you might have noticed your faceplate may have a different color scheme. Mine is a grape faceplate with blue accents, blue and green. And in blue, above the numbers 1 through 6, you see L1, L2, L3, L4, L5, L6. Those are my basic list names. There's plenty other lists, but those are the most common that we use. I'm going to go, since it's in blue, anytime I want anything in blue, I hit the second key right here in the top left, second, and number 1, and it gives me L1. Now close the parenthesis. Your right parenthesis is above the number 9. Close the parenthesis, hit enter. You'll see that it says done, but you don't see anything. It's been done. To see it, you go back to stat. You keep edit highlighted and you hit enter. And now you can see that that's the same list that I had a few minutes ago, but now it's been sorted for me. Okay. So now I have my sorted list. Now the next thing I want to do, once it's been sorted, is I need to, okay, so what are we doing here? Let's go back to our whiteboard for a second. Let me get another whiteboard here. So we're going to construct oops, a grouped frequency distribution. So what do? You enter the given data into the calculator and sort it in ascending order from lowest to high. Okay, so we did that. The next thing we want to do is we want to find the minimum and the maximum. Okay, so a couple of ways to do this. You're going to learn a few ways, but probably the easiest way right now, with what we know in the course, is the lowest number, because you've sorted it, is going to be at the very top of your list. So the lowest number here is 465. And now the highest number is going to be at the bottom. And you could scroll down using the arrow keys. You could scroll all the way down. And you could find that it's 514. So 465 and 514. Now, there's another way to do this that's really cool. If you're in the first slot, if you want to get to the bottom of any list, and this also applies to a menu, you can hit the up arrow key twice, and it'll take you to the bottom. Now, why did I have to hit it twice? If you do it again, this doesn't take you to the top, unfortunately. It doesn't, we don't have that same shortcut for the top of your list. But if you go out and come back in, you'll end up at the top. So here, 465 and 514. So we're going to have my highest value. So I have my highest value, or my maximum, is 514. My lowest is 465. Okay. So the next thing you want to do is you want to find the range. Find the range. Now the range, we're going to learn a lot more about this later, but the range is always the maximum minus the minimum, the highest minus the lowest. So we have 514 minus 465. Okay, that's going to give us our range. So what I'm going to do here is I'm going to go back to the calculator. And I'm going to quit from here because I want to use the calculator for a calculation. 514 minus 465 comes out to 49. Okay, so I'm going to take this is 49. Now, what I'm going to do then is I'm going to say, okay, this is 49. Now, I'm going to say, I'm going to find the class width. Okay. And the way you find the class width in this class is you take the width is going to equal the range, which is why we needed to find it first, divided by the number of classes that you want to make. So we know what the range is. We just calculated it a minute ago. And the number of classes is given to us in the problem. So let's look at that now. We're going to go to the homework assignment here. And it says that we want 6 classes, she said. So we're going to come back here and we're going to calculate the width to be, the width is going to equal 49 divided by 6. And if we take our calculator now, I'm going to go to my calculator screen. We're going to take 49 divided by 6. This is going to give us 8.166 repeating, okay? 8.166 repeating. So now we have, we usually round to 4 decimal places in this class. We're going to round to a whole number in just a minute. I'm going to take this and make that 7. But remember, we want the width. We want the width to be odd. So even though this is only 8.1, okay, 8 is even, okay? And normally this would stay 8, but we want the width to be odd. So we're going to make the width the next available odd number. And so the width for this problem is going to be 9, because that's the next available odd that we have, okay? So our width is 9 units. That's all of our setup. We haven't made the frequency distribution yet, but we have all the numbers now that we need to do it. So we're going to make our frequency distribution table on the next slide. So now we're going to have some drawing to do. Oops, hello, not that. Let me erase this. Okay. I'm going to bear with me for a minute. I'm going to fix this up. So, okay, so now we have a chart that looks like this. I put some reminders over here for us because this is the relevant data that we need right now. Now, to get the class limits, we start from the lowest value, which is 465. Now, here's the first mistake that people make on this. The class width, we're gonna add 9. That's not the end of this class. It's the beginning of the next class. So if we add, let me show you on the calculator here. And there's no reason why you should be doing this in your head. You're more than welcome to use a calculator at all times in this class. You just have to show your work. 465 plus 9 gives me 474. Plus 9, 483. Plus 9, and so forth, okay? So 474, 483. Let's go back. So we have 474, 483. We're going to add 9 every time. If we add 9 to 483, we get 492. And if we add 9, we get 501. So we keep going until we get enough classes. Right now, we only have 4. We need 2 more, right? So we add 9, add 9 here, add 9 here. So we get, let's go to the calculator here. We get 492 plus 9. We get 501. We add 9. We get 510. I'm going to add 9 one more time. You'll see why in a minute. So it's, okay, so there's my, now, this is, so 492, 501, 510. So we have 501, 510. Now remember, this is only my lower limit. And I'm going to add 519. I'm going to make this go away eventually. I know it's a extra class. You'll see why I'm doing it in a second. Now, this is the lower limit. To get the upper limit for this class up here, to get the upper limit for this class, the number that goes here, you take 1 off of the class below it. So this is 474, so this is going to be 473. 473. That's the easiest way. It's not the only way. You can, once you get this number, you can add 9 to it, just like you did before. but this is going to be 482. Okay. So if you add 9 to 473, you get 482. So 482, you add 9 again. Look at the class below this one, which starts with 492, and take 1 off. This is 491. This is 500. This is 509. This is 509. And this is, we're adding 9. Now, this is why, maybe now you can see it. This is why I put an extra number down here. You don't need 519, but if you're using the method that I described, there are you are now. What I'm going to do, for the sake of clarity, I'm going to get rid of this element down here. I'm going to get rid of that. So I take my here and I'm going to get rid of it. These are my class limits. Okay. Now, some of you have been watching the video on class boundaries. These are whole numbers. So we want this class limit to be below 465, so that it'll round there. So we're going to take half a unit off. This is going to be 464.5, okay? Because I'm taking half a unit off of that. So this is, let me show you that. So this is 465. Again, these are whole numbers. So we have 465 minus 0.5. The 0 is optional, but I always put it in so you can see where the decimal is. 464.5. Now, the other class limit, I'm going to add 0.5 because I wanted to include the number that I'm dealing with. So I'm going to say that this is 473.5. So this is 473.5. Now, it's a pattern after that. You're going to repeat because these ones overlap, okay? These numbers overlap each other. 473.5 to 482.5. So this is 482.5. Then I have 482.5 to 491.5 and 491.5 to 500.5, 500.5 to 509.5 and 509.5 to 518.5 to 518.5. Okay, that's all the math that I have to do. Now, the next question I get asked is, how do I find this frequency? It's not given to me, I don't know. This is where a lot of students go in and count, and you're welcome to do that. You can count on the calculator if you like. So what I'm going to do is I'm going to count all my numbers. I know it starts at 465. I'm going to count for this first class. I'm going to count my numbers that are on my list between 465 and before 474. So up to 473. Okay. I'm going to count how many there are. So if I go over here and I say, here's my data. Let me go back. Remember to see your list, go to Stat, Edit, and just count on your screen. So we're counting until we see now 473 counts, but the 475 doesn't. So there are 9 elements that go up to 473. So I'm going to go ahead now and say that there are 9 of these. So that's a frequency 9. Okay. Now we're going to count from 474 to 482 inclusive. Okay. So 474 to 482. So we have that's 1. Start with position 10. 1, 2, 3, 4, 5, 6, 7, and we stop there because that's 483. So 7 elements in the next one. So we have 7 elements here. 7 elements. Now we're going to count from 483 to 491. So we have 483 to 491. 1, 2, 3, 4, 5, 6, 7. 7 elements here. So we're going to go to 7. So we're going to say this is 7 elements. Okay. Now we're going to go from 492 to 500. So we have 1, 2, 3, 4, 5, 6. Stop there. 6. So we have 6 elements in this class. We have 6 numbers that fit that. And I'm just going to move it over so we have. Okay. Now we go from 501 to 509. So we're going to say 1, 2, 3, 4, 5, 6, 7. Stop there. Okay. So we stop there. We have 7 elements. So we get 7 elements in this group. And then the rest of them are going to be in this last section. So we have from 510 to 518. So we have 1, 2, 3, 4. There are 4 of them. Okay. There are 4. So we're going to fill this in with 4. Now, it's always a good idea to check your arithmetic. It's easy to miss a number. We're going to do that with the cumulative frequency. Now, the cumulative frequency, the first cumulative frequency always matches the first frequency on your list. So this is your freebie number. These two numbers here will always match because that's how you start. Now, to get the next cumulative frequency, you're going to take the cumulative frequency right here and add the frequency below it. Okay, so 9 plus 7, this is going to give us, and you can show this work. You don't have to show everything all the way down. I will here just for the sake of clarity, but you do need to show the first so you know how you got it. 16. Then we're going to say this is 16 plus 7. Feel free to use a calculator if you need to, but 16 plus 7 is 23. 23 plus 6 is 29. So this is 29. 29 plus 7 is 36. 29 plus 7 is 36. And 36 plus 4 is 40. Now, if you add, this is 40. If you add all of your frequencies, 9 plus 7, 16. 16 plus 7, 23. 23 plus 6, 29. 29 plus 7, 36. 36 plus 4. This total, if you add up the total, independent of your cumulative frequency, these totals should always match each other. That's a way for you to check to make sure you didn't miss anything. Your last cumulative frequency should match the total of all of your frequencies. So let me put that over here as a note. As a check, the last cumulative frequency should be the same as the total of the entire frequency column, the sum of all the frequencies. Okay, that, and it does work. And this is your group frequency distribution for this problem. Okay, I hope that helps you, and I will see you in my next video very soon. Stay safe, everyone. Be healthy. Thank you for watching.